Welcome to this Chamber Low Carbon Live Lunch and Learn. I'm Stephen Sykes and I manage the Chamber Low Carbon Programme, and I'm your host for today's session. Just a few housekeeping items before we start. All participants are on mute, so if you've got any questions, please use the Q&A facility at the bottom of your screen. My colleague Debbie Treadwell and myself will be monitoring to capture your questions. There is also a chat function to introduce yourself and say hello to the room and where you're from if you wish. Today's session is being recorded and will be available to watch again on the Chamber Low Carbon YouTube channel. For those unfamiliar with the programme, Chamber Low Carbon is brought to you by East Lancashire Chamber of Commerce in partnership with North and Western Lancashire Chamber of Commerce, Business-Wise Solutions and Boost, supporting businesses across Lancashire to go green, save money and reduce their carbon footprint. Part funded by the European Union European Regional Development Fund, this £6 million programme provides a suite of free services to help businesses to improve their energy and environmental efficiencies, introduce on-site renewable energy generation, and by doing so, save money. The programme also helps Lancashire businesses that are developing new low-carbon technologies to bring their products to market, facilitate them being manufactured in Lancashire, and help them find demonstrator sites within Lancashire. Today's live Lunch and Learn is brought to you by Andy Brunt and John Pickup, both directors of Ejim Efficiency, a Lancashire-based energy and sustainable building specialist. Ejim have over 80 years collective experience across sustainable building design, efficient systems, green technologies, and Andy and John have worked with Chamber Low Carbon Programme across the county, helping SMEs from all sectors to cut their energy consumption, reduce costs, and invest in low carbon generation. So without any further ado, I would like to welcome Andy and John and invite them to take over the screen.
Thanks, Stephen, and thanks for the opportunity to talk to you about these issues this afternoon. I'm Andy Brunt, I'm Director of Ejim Efficiency, and I'm joined today by my co-director, John Pickup. John will be delivering the second and vastly more interesting part of the presentation today. Just by way of background, I've personally been active in sustainability related issues for 20-something years in a number of different contexts and roles. My background is environmental science, and my particular discipline is sustainable energy and how that relates in particular to the built environment. Conscious that we have other priorities right now with the COVID-19 situation on top of our usual day jobs, and also that we're probably at different levels of experience with regard to energy related issues and so on. But if we're able to achieve one take-home message from this presentation, I'm hoping to convince you that we all need to take energy use within our organisations and particularly our buildings seriously, far more seriously than perhaps many of us have been doing to date. And also that if we do that, this can have really positive synergies with what we're trying to achieve in other aspects of our business activities. So this might be a slightly whistle-top tour of some of these issues, but hopefully we can discuss and pick up any specifics you feel are most relevant in the questions afterwards. So from an ecological perspective, I think there's considerable understanding and urgency in bringing about concerted action to address a range of interconnected issues, climate change, habitat loss, the rest of it. And as a colleague put it recently, if you like coronavirus, you're going to love climate change. But I think from the perspective of companies across all sectors, really, the impacts will also be felt in terms of increasing environmental regulation, although that obviously depends on government to a degree, but also increasing costs, which might be having a slight wobble in the context of current demand or unexpected demand reduction. But there's a clear trajectory of increasing costs alongside stakeholder pressure to be responsible and sustainable. So turning to the issue of energy in more detail, I think one statistic which quite often surprises people, is that energy can be the second or third largest cost in an organisation after staff costs, raw materials, and sometimes building related costs. But it massively impacts the bottom line, and it's often treated as a fixed cost, when in reality it's very capable of being managed and reduced. So the principles of energy management, which I won't go through in detail today, but they can be summarised as you see on the slide. Basically, understand how much you spend, where it's being used, buy green and buy it as cheaply as possible, use as little as possible in your operations, so make sure you've got efficient systems and procedures, keep everything under review, and then analyse and monitor your progress over time. And obviously, the extent to which you monitor and control your energy consumption dictates how effective your overall approach to energy is going to be. So in the context of buildings, the first priorities obviously should be to minimise energy demand, which means taking a fabric first approach. Within a building, heat can only be lost in a certain number of ways, and that's basically through the fabric, via the walls, the roof, the floor, the windows and the doors. And the rate of that loss depends on a number of factors. John's going to be taking you through these issues in a bit more detail, but basically temperature differences, air tightness, the thermal characteristics of the fabric, and the orientation, form and layout of the building and the various parts of it. So here you can see some indication of the relative significance of each of these elements in the context of a typical industrial building in the UK. You can see each element contributes significantly to the total, with air movement being the single factor, followed by roof, floor, walls, and apertures. Okay, I'm going to pass over the baton to John, who's going to, as I say, look at some of these issues in a bit more depth.
Thank you very much, Andy, and thank you for the opportunity to present. My name is John Pickup. I am a director of Edge Efficiency. I'm also a registered RIBA architect and client design advisor. And I think over the last probably 20 years, I've come to realise that not one particular profession has all the answers. We have to rely on other people that have more skills than us, and therefore working with Andy on the environmental side and Will on the engineering side and me on the architecture side, it's kind of the holy trinity really when it comes to sustainability. It's very difficult to purely isolate fabric as one element, but I'll be doing that and showing some examples of where buildings, some of the problems that have been faced by clients and how those have been overcome. Just to start then, we looked at, there's numerous definitions out there for what is a sustainable building. We chose the one from the Global Development Research Centre, A, because it's very current, and B, because we think that's a decent definition because it actually links buildings to behaviour. And I think that's one of the fundamental principles of improving the environmental credentials of any building, any client and sector. So how do we do it? I think the right approach is essential. It's establishing that at the outset. It's understanding the client, and it's undertaking a site visit. So we look at simple things such as site layout, access, orientation, condition of the building, age, and we look at, the earlier the intervention, the better. So if any work is planned, now is the time to embed some of those sustainable principles within the opportunity, and we want to be clear and concise about what those opportunities are with the client. And I think fundamental, and something that's we've become more and more sort of geared to and understand, is that we need to establish what the budget is, what the client is looking for in terms of outcome, but what they're prepared to invest in over what period. And so really it's getting to know the brief. What are the key drivers from each of the from each client. Everybody's different. So move on to the next slide, Andy, if that's okay. So just in terms of talking about getting to know the the client, all clients are different, all sectors are different, and the drivers are different. So they could be financial, they could be based on an improved marketing potential by being seen to be green, if you will, or it might be something like a supply chain requirement where external clients and suppliers are demanding certain environmental credentials for bids to go in on particular work. Budgets have to be realistic, and therefore there has to be a little bit of iterative approach at the outset to establish what you can do, then get some basic costs. One of our key discussions with clients is the benefit of actually improving building fabric from an asset point of view. So if one of the drivers for the client is to perhaps sell the building in due course, then obviously it will reach a greater market value the more environmentally sustainable it is, the more energy efficient. Different skill and different personnel. I think everybody has a slightly different understanding of what sustainability is. So it's understanding what level of discussions we're starting to engage with clients on, so we can advise in the best way, and try and tease out of them what their key objectives are essentially. We measure the buildings. Buildings are all different. We measure the buildings, do a survey to establish what we're dealing with. And one issue that's come up a number of times, particularly through Chamber, is ownership of the building. So if you're an owner occupier, you've got a lot more free rein to do something with that building than perhaps if it's leased. But again, the asset value increase is a discussion that can then perhaps go to the owner of the building in terms of the longer term benefit of investing in that facility at that moment in time. Thank you, Andy. So we've been through a number of, over the years, a number of different sort of elements of assessment for buildings, and we've put together just a list there of 8 key areas that we focus in on. And I think above all, the first and foremost is to look at air tightness, and that can be looking at air leakage through fabric in terms of gaps here and there. But it also can be through operation as well, and I don't think you can disassociate those. So, perhaps you have an industrial building with big roller shutter doors either side. There seems little point in improving the fabric significantly if those doors are going to be open and it acts as a wind tunnel. So again, understanding operations absolutely key, and applying that air tightness, because you want to keep the volume of air in, and then you can apply decent calculations to that to improve the temperature within that space, and you can control it better. Air tightness then runs into insulation, and applying insulation within an existing building can be quite disruptive. So again, where that is best positioned and what impact that might have on the client is something that is fairly key to understanding how we can advise people in the most appropriate way. Control, it could be physical in terms of the way that the building is set out, or it could be down to mechanical, electrical engineering installations where we can perhaps advise on zoning the building, which would improve its thermal performance. Thermal mass, lightweight buildings lose more heat than more dense buildings if it's a brick and block building as opposed to a lightweight industrial building. But again, having a look at that and how that impacts an operation. Controlling natural light and sustainable materials, embedded carbon footprint in materials is something that you look at once you've got a schedule of activities that can actually improve, that you want to apply to that particular building. And again, understanding constraints. There might be structural constraints in terms of putting PV on roofs, and again, operation. And try and embed technology. Try and make sure that the technology is designed appropriately for that building, and that's where you can potentially look at a phased introduction of these elements. But it's about linking investment to output. You want the biggest bang for your buck. Thanks, Andy. So just a few illustrations, a few examples. The world of building fabric is quite a wide area, and these are just a few examples of how you need to be quite creative sometimes in terms of improving the performance. So the one on the left hand side is domestic residence. We looked at improving the air tightness of the building through construction. The impact of doing that, and a lot of it is not heavy in terms of technology. It involves an awful lot of tape and sticking things over holes essentially. But if you can do that, then in this instance, it resulted in a reduction of specification for the heating and ventilation plant because the building was performing better. So doing that at the front end, making those calculations means that the client saved a considerable amount of money. On the insulation one, again, a domestic situation close to my heart because it's related to, even though the images aren't, but it's related to my property. We've got polystyrene ball blown insulation in the cavities. There's a problem with that in that it's not basically stuck together, and over time it drapes into the cavity, and so the top end of the building becomes cold and the bottom end warm, and that gives rise to all sorts of issues in terms of dampness and mold growth, etc., where you've got that difference of temperature of external walls. So I think the impact there, the issue there, is to understand if any environmental interventions have been undertaken in the past and whether those will have a negative effect going forward. So actually understanding the nature of the building that you're dealing with. The one on the right hand side, control, that relates to a hotel in Wales. We were invited to have a look at a quote for a new heating system, which was quite considerably high. We found that it was based on a like-for-like replacement, even though the building was only 4/5 the size that it was when the first installation was put in. And we talked not only about the efficiency of boilers and what we could do to existing windows and fabric, etc., but we also looked at control in terms of how the hotel is filled. And filling the hotel from the bottom up means you can isolate floors, save money, rather than filling from the front to the back because everybody wants to see view. So it's about the control of operation as well as fabric. Thanks, Andy. Natural light. We are looking at an industrial building in Lancashire at the moment to re-roof that building. It's over an operating area. The client can't afford to shut that down for any length of time. So the logistics of actually replacing the roof are quite considerable. We've come up with a solution that allows it to be phased and do it in sections. So from a health and safety point of view, we can address those. But I think the illustrations on the slide there just show that the existing roof lights are nigh on useless in terms of allowing natural light into the building. And by replacing the roof and getting insulation in the roof, you can introduce insulated roof lights, which then reduce your demand on your lighting and your electricity demand, which I think there has to be, as much as possible, a multiple benefit to any environmental intervention, but it isn't a one size fits all. And that's, I suppose, shown on the second one there were embedded technology. There's a couple of domestic designs there. The top one's in Greenbelt. The planners wouldn't allow big A-frames and PV on the roof, so we had to reduce the inclination of that to hide it behind a parapet. And because of that, we had to have more PV because it wasn't efficient. But understanding that at the outset is fairly fundamental to this, along with other technologies that link into that particular building. Bottom one, we're just doing some design work on at the moment, and again, photovoltaics are a key element in terms of the putting energy into the building, and those photovoltaics will be again greenbelt. It's the building's a bit like a pea on a drum. The planners don't want any domestic paraphernalia, as they call it, on show. So we're introducing a ha-ha to stop animals approaching the property, and on the south-facing slope of the ha-ha will embed photovoltaics to feed into the building. So again, there's a dual benefit in looking at how you introduce these creative elements.
I just want to is John, because I didn't know.
It's a ditch in the ground that avoids you having to put fences around buildings. Basically, it's a Victorian way of stopping animals approaching properties. It's quite cool, actually. But so now, just moving on to detail, we are presently looking at a Methodist church in Brighouse, and as you can see from the thermal images, we did a thermal imaging survey of the building. The building is Grade 2 star listed. There's very, very little you can actually do to the fabric that will be acceptable, and therefore you have to design the system according to what is achievable rather than it being idealistic. It's got to be realistic rather than idealistic. So what we suggested there is that, realign part of the ceiling within some of these activity spaces. Because there were decorative trusses, we couldn't go for the depth of insulation that we wanted to, so we've had to reduce the depth of insulation so we still maintain the visibility of these trusses. And so we looked elsewhere for environmental improvements and how do we reduce heat loss through the building. Instead of looking in the areas that we're actually doing, so dealing with, so the yellow area and the pink area in the middle of the two main activity spaces being created, look at the areas that feed into that. So we're looking at creating better buffer zones so that when the doors are open, the air isn't being sucked through those spaces. So if we can increase the natural temperature between the approach spaces and the activity spaces, then that heat loss is more controllable. And you can do that by upgrading existing doors and draft proofing and lining windows, etc. So I think, again, being creative about building fabric, you can do something positive to any building. It just has to be appropriate to the particular client, building, age, etc. Thank you, Andy. And it has to be it's an iterative process. I mean, the key for us is to determine the budget as quickly as possible. And sometimes clients need to have information in front of them to find out what budget that is. There is a desire to improve their buildings, but unless and until they know what options are available, that budget can't be defined. So, do your due diligence at the outset, do your measurements in terms of what the building is using over a given period of time, and that certainly has to be over a year, so you see seasonal differences. And also, if possible, if there's any particular spikes in terms of energy use from certain elements rather than just general heating, it might be operation and machinery, etc. So again, understanding buildings' use and patterns is key. Provide some calculations and present a series of options to the client. That then really comes back and defines the true budget. And once we know what that is, we can start looking at either a full implementation strategy or a phased implementation strategy, so that what we're putting in now doesn't preclude any further improvements further on down the line. And the way to do that, obviously, value for money is important. Obviously, clients want to see that there's some competitive tenders, competitive quotes that are coming in for the various elements, and the production of a performance specification to tie down any areas that might be subject to interpretation from different contractors is really important. So what it has to achieve. So that's a basic performance spec that then can be detailed up further, but using that as a basis to get competitive tenders, competitive quotes, I think is very, very important. And then managing and integrating the installations. It may be that you've got somebody looking at the roofs, somebody looking at the windows, somebody looking at lining walls, or so there might be a number of different contractors. Management of that to make sure that that doesn't adversely impact on the business as a whole. I think that's key. That's where we sit as well, to make sure that's aligned. And then the other thing that we want to try and avoid as much as possible, and that's getting away from the fact that it's not a one-size-fits-all solution, isn't environmental improvement and upgrade. It's making sure that you measure the successes. So avoid being avoid selling a bit of kit with oversold benefits and then never being seen again, but actually going back in and monitoring the success of those improvements. That, I think, forges or gives you a better opportunity to forge a critical partnership. And I think the impact of environmental sustainability and increasing energy prices means that a lot of organizations, a lot of clients perhaps don't have the internal skills to manage that on an ongoing basis. And the opportunity to provide almost like an environmental FM support structure to that client, I think, is key. And it's about trust and partnership. So, I think no two buildings are the same, no two clients are the same. So why should environmental solutions and fabric upgrades be the same? They have to be entirely specific. Over to you, Andy.
Brilliant. Thanks for that, John. Well, I just wanted to finish off with just a few words really on why we started Edge and what our ethos is. And we set Edge up specifically to cover energy from an integrated perspective. So as John said, the sort of disciplines being design, architecture, environmental sustainability, and engineering of systems to bring about a holistic approach to energy use within the buildings. Obviously, that varies depending on whether you're starting from scratch with a completely open design brief, or whether you're looking at a specific, narrowly defined refurbishment project. But the approach is the same, and it's based squarely on the interface between those disciplines. We work with clients to ensure that both their buildings and their operations are as efficient as possible. So we do this by providing a range of services to clients, really, as John said, from initial assessment of what the current benchmark is in terms of energy performance, to producing and implementing detailed improvement strategies. We can work with you and save money and energy, whether you're a two-man enterprise in a rented unit or a multinational company operating from dozens of sites around the world. Again, as John said, we genuinely treat each client as an individual. I think we recognise that the sort of generic approach to this type of issue isn't the most effective method. And that all organisations have unique characteristics and issues which need to be taken fully into account. We're genuinely independent. We have no ties to specific manufacturers or technologies, so the solutions that we derive are only ever the one that works best for the particular client. Okay, I think that's probably enough from us today, and thanks for joining us, those who were able. Thanks for listening through. I'll hand back to Stephen for the closing slide, and then if there's any questions, we can take those at the end and try and listen to what you've got to say.
Thanks for that. I was just going to say, if there are any questions, if you could raise your hand or type it into the Q&A so we can pick you up. I can switch your microphones on and you can actually pose your questions directly. We don't appear to have any questions at the moment. One thing, possibly to John more. In East Lancashire, we have a raft of more traditional buildings or former mills and things. What type of challenge do they present? to you in terms of improving the efficiency?
I think some of the bigger mills, and I'm a great advocate for maintaining our industrial heritage. There aren't many of those mills that are singularly occupied, if you will. Therefore, there's a number of different businesses within some of these bigger mills, and I think that's one of the issues. You know, it's what you would like to do in an ideal world is look at the whole building fabric, the envelope of a building rather than a part of it. But you quite often have to target particular areas within a building because of the usage. I think there's some real benefits in some of those buildings. You know, there's the heavy structures, the thick walls. You know, your starting point is good, but they were always fairly airy buildings, so they didn't really have a great deal of attention applied to them in terms of air tightness. Size of openings is an issue, and that can become quite expensive when you start to look at perhaps window replacement strategies and things of this nature. But I think what it comes down to in a lot of ways is making sure that whatever intervention you apply doesn't adversely affect the fabric. So if you put insulation in the wrong area, you're getting dew points in the centres of walls where it's not really ideally positioned, and you can create longer term problems by doing that. So I think this is about being creative. I think these are industrial buildings, a lot of them, as you say, the mills, and there's industrial solutions, I think, to them as well. And the Victorians would have built them different had they had access to the technologies that are currently available. So applying that logic, you can come up with some very interesting solutions. And control in solar gain, for example. They were just built on pieces of land. It wasn't particularly they weren't particularly focusing on making sure that the south-facing windows were overshaded and things of this nature. So it's understanding operation and then applying logic to the solution.
I was almost anticipating some of that, but I was also intrigued by the slide that you had up regarding the church. I did back in my dim and distant past, when I used to work for groundwork, I did some work with Operation Eden, and I did a number of sustainability reviews of places of worship, and grade 2 listed churches heating systems can be quite a challenge, because some of them were I think that the boilers were built just before the Titanic engines.
Yes. Yeah.
So,
well, again, I think when you're talking about listing, you need to limit the impact on the fabric as much as possible. And so if you just part the walls and floors and windows for the time being, but the existing heating system is generally channeled through ductwork in the floor that's got big cast iron radiators, flow and returns, well, maintain that. You can't rip those up and put new squeaky clean stuff in. It will be inappropriate from an aesthetic and a vernacular perspective. But if you can maintain the distribution system but put a better energy source in, and then look to redistribute the warmer air within the building. I mean, certainly in Brighouse, it's a big worship space. It's really warm. If you were clinging into the ceiling for an hour during the service, you'd be warm as anything. It's the people on the floor in the pews that are cold. And so how do you recirculate the air, so it's de-strat fans, or it's some clever redistribution of that heat. And it's getting these buildings up to a workable temperature quicker than they presently are. So in Brighouse, I think somebody goes in at 6 in the morning for an 11 o'clock service, and they put the heating on, and it needs to be on for 4 or 5 hours. And it heats from the top down. Well, that's got to be wrong, and there are certain ways that you have to look at that. But again, each property, each building throws up its own challenges, and being site specific is fundamental.
I think also, churches it's a good example of organisations and buildings that you also have to get into sort of understanding how the buildings are used by the various categories of user group, and what those timings are, and whether there's really opportunity at a sort of management level to say, well, look, we're heating this entire space for like a group of 3 people to come in at 4 o'clock, and you do some music or something like that for an hour or whatever it might be. There's better approaches, and I think taking a sort of taking that as a starting point and having a look at that, and factoring that into the approach that you take to the overall building, looking for opportunities to improve usage profiles and occupancy levels and things like that. Applies to a wide range of building types, but yeah, also churches, I think it's significant for them too.
Oh,
Okay.
Andy seemed to disappear there.
Oh, right. Okay. I'm not seeing any questions in the Q&A or indeed in the chat. So if there are no further questions, I'd like to thank Andy and John for their time, expertise and insights today, and also to thank you for your attendance. I hope you found it interesting. To find out about our next Lunch and Learn, if you could go to the Chamber Low Carbon website for more details and register there. Please keep in touch with us via the media channels on your screen. And until we see you again, on behalf of Andy, John, the Chamber Low Carbon team and myself, be alert and stay safe.